Hi guys, welcome to my YouTube channel. In this video we will see how to make a line following robot. First we have the components which we need to make the line following robot. We have an L293D motor driver IC, two 40667 ICs which are 16x1 multiplexers, 4 infrared sensors, one 12-volt battery, one LM7805 5-volt regulator, some connector blocks, car chassis, glass fiber PCB board and FeCl3 solution. First we have infrared sensors. In infrared sensor we have two LEDs. One is emitting LED and the other is receiving LED. The emitting LED emits light in the infrared region which the receiver receives and the sensor works according to it. Here we have three pins. One is VCC, the central pin is ground and this pin is output. We will give 5 volt to the sensor through VCC. We will provide ground to this pin and then we have our output from this pin. Here this is a rheostat which is used to adjust the distance or range of infrared sensor. Whenever a bright surface comes in front of a sensor, the emitter emits light and the light is reflected back to the receiver and the receiver then provides us the output. This is a 16x1 multiplexer IC. It has 16 input pins, one common output pin, 4 selector switches, one ground, an enable and a VCC pin. How data is selected from these pins? From the input pins. In this table we can see we have 4 sensors as output. When all the sensors are 0 means they are under a white surface, then input 0 is selected as output of the mux. When the output is 0001 means the one pin is selected as the output. So we have 16 combinations of sensors for different selections of pins. This is how our mux use. Here we have a 16-pin motor driver IC. Pin number 3 and pin number 6 are for left motor. Pin number 14 and 11 are for right motor. Pin number 2, 15, 7 and 10 are used for input. The output from the mux will come at pin number 2 and 15. Pin number 2 and 15 are responsible to drive the motor in forward direction, while pin number 7 and 10 will drive the motor in backward direction. As in our case, we only need our motor to run in the forward direction. We are using only pin number 2 and pin number 15. The output from mux 1 will come at pin number 2 and output from mux 2 will come at pin number 15. Here is the most common pin of the IC, which is pin number 8. It is used to control the speed of the motor. We will provide high voltage at this pin in order to run our motor fast. Response time of sensor will decrease. Thus, we will provide only 12 volt at pin number 8. While the other VCC pins of L293D will be given 5 volt. This is the logical table which tells us how our motor will react according to the sensor inputs. When all the sensors are under a bright surface, then we want our car to rotate. To do this, we will turn off one motor and the other motor will still working. When the rightmost sensor is under a black surface, it means that there is a right turn in the track. So, we will turn off the right motor but the left motor will still working. Thus, the car will rotate towards the right. When central right sensor is under black surface, same condition will apply. And same is the condition when both of the sensors are under a black surface. If central left sensor is at black surface, it means that there is a left turn in the track. So, we will turn off our left motor and our right motor will rotate the car in the left direction. Here is the don't care condition. In don't care condition, whatever we apply at the motors, it will not affect the working of the car because this condition is not possible in the track. Here is another don't care condition which cannot come in the track, which is both the left sensors are under a black surface. Thus, whatever we applied at the motors will not work. These are some other don't care conditions. Here is the last condition, which is when all the sensors are under a black surface, then both of the motors will stop and our car will also stop. This is a Proteus simulation which shows we have 4 sensors S0, S1, S2 and S3. This is the voltage regulator which will convert 12 volt to 5 volt. This is a 12 volt battery. This is our motor driver IC. These are motors and this is multiplexer circuit. This is multiplexer 2, this is multiplexer 1. They have made by using their logic diagram or their logical table. Now, here the logical diagram is replaced by the Mux IC. Now I will describe you the connections. From this 12-volt battery, we have given 12 volt to pin number 8. All the ground pins are grounded and the other pins are VCC. The output of the Mux 1 will be given at pin number 2 of L293D and output of Mux 2 will be given at pin number 15. The output from the sensors will come at selector switches of both the muxes. The VCC input of sensors is connected to regulator 5 volt and other pins are grounded. Now here are the connections which we will use to run motors. At conditions when we want our left motor to work, we will connect those pins to VCC, and the conditions in which we want our left motor to stop, we will connect that pins to ground. Thus when an input is selected, the motor will run accordingly. If the pin holds 5 volt, then the motor will run, otherwise it will stop. Same is the case for Mux 2. Here is how we provided VCC and ground to input pins. Pin number 0, 4, 6, 8, 9, 10, 12, 13, 14 and 15 are given ground and the rest of the pins are given VCC. This is made according to the table which I have explained before. You can also see the Mux 2 connections. Moving on the PCB, this is the PCB which I have made for my LFR. It will also be provided in the description link. Here is the 3D visualizer of the PCB board. This is how our PCB will look like. Now what you have to do is to just take print out of that PCB board. The printout will look like this. Here will be Mux 1, Mux 2 is placed over here. Here will be the L293D motor driver. These are for the connector blocks of motors. This is to connect battery. Here will be our voltage regulator. These wires will go to the VCC of sensors. This is to provide ground to sensors and the output of the sensors will be given at these points. This is the path which I have made for my PCB. As you can see, here are connector blocks for the sensors S0, S1, S2 and S3. These wires are going to VCC of sensors. These will go to ground. These are muxes. This is L293D motor driver. This is my voltage regulator. This is connector block for left motor. This is for right and this one is for battery. These are the applications of infrared sensors in the industry. They are used in gas warning devices, gas analyzers, medical gas measurement technology, flame detectors, contactless precision temperature measurements. They are also used in obstacle avoidance. These devices use the intensity measurement of infrared radiation in defined spectral ranges. For any query, you can ask in the comments and don't forget to like, share and subscribe.